right, so today is November 17th, and we're taking a look at that section 4-4. All right, now the first thing we're going to do is we're going to, up to this point, you've been dealing with trig functions, trig ratios, and we have focused on that unit circle, okay? And that's good, but a unit circle is only one type of circle that we're going to encounter. All right, if we just review a little bit before we get started here, a unit circle, well, what is a unit circle? A unit circle is going to have a distance of a radius of just 1 unit. All right, and so every one of our definitions for sine, cosine, tangent, cosecant, secant, and cotangent up to this point have been based on a unit circle with radius 1. All right, however, that's not the only type of circle that we're going to encounter, okay? We want to be able to have a circle with any size radius. All right, any size radius. Let some people in the waiting room here. So to do that, all right, we've got to come up with some new definitions. All right, we're going to have a random point on our circle somewhere, maybe say right there. If it's a random point around that circle, about the only thing I know about that is I know the coordinates are going to be x, y, right? Because in an ordered pair, the first point is the x coordinate and that second point is the y coordinate. All right, so this is what we're going to focus on today. All right, and all it's going to do, you're going to have 6 new definitions you have to memorize, but then you're also going to have to do a step 1 before you actually implement those formulas. You're going to actually have to find that radius. They're going to give you the point on the circle, and you're going to need to use a little bit of Pythagorean theorem there to come up with that radius. Okay, so that's just kind of the direction that we're going. All right, so let's write our definitions that we got to memorize down first. Okay, so these are going to be our trig functions using a circle with radius r. Okay, so our radius can be anything. So any radius that we want. All right, so let's be a little bit more specific so that you don't get these confused with our other formulas. This is not a unit circle. You will not use these definitions if they tell you in the problem that you have a unit circle. Okay, so again, there are 6 of them. So let's say we've got sine theta. All right, we'll have cosine theta, we'll have tangent theta. And again, I'm going to write these 6 in a certain way because it's going to help you memorize them. Okay, so cosecant theta, and then we're going to have secant theta, and then we're going to have cotangent theta. All right, and again, writing them in this way, sine, cosine, tangent, cosecant, secant, cotangent, these 3 are the reciprocals of these. All right, now, if you remember on our unit circle, we defined sine as y, cosine as x, and tangent as y over x. All right, so that basically, if you stop and think about how I write y, if I have just the variable y and I want to turn that into a fraction, I'm going to do y over 1, right? Okay, just go with me here for a minute. If I've got just a random variable x and I want to turn that into a fraction, I'm going to go x over 1. All right, I just put it over 1. All right, we used x and y right here when we were defining our functions on a unit circle. Okay, there's the 1 from the unit circle. That was the radius of the unit circle. Okay, but we didn't write it because no one writes y over 1. You just write down y. All right, so now if I'm going to have a circle of radius r, all I have to do is replace that 1 with an r. So this formula becomes a y over r. Okay, it's the exact same formula. So really, you're not memorizing a new set of 6 formulas. You're just replacing the 1, the imaginary one that we weren't seeing, with whatever the radius is in the circle. So y over r, x over r. All right, and now tangent was defined as y over x. So it's still going to be defined as y over x because that's a point on the circle. The y and the x is not going to change. All right, once you have these 3 memorized, then these are the reciprocals. So this becomes r over y, this becomes r over x, and this becomes x over y. And if you remember when we defined these before, this was 1 over y, this was 1 over x. Okay, so we're replacing that 1 with our radius. Okay, so those are your 6 trig functions and the way they are defined when you have a circle with radius r. All right, we're going to use these then to work out a problem and find all of our 6 trig functions when given a random point on a random circle with radius r. Okay, so as an example, they're going to give you a point, maybe say 4, -3. Okay, they are then going to tell you to find all 6 trig functions. All right, now how clearly or how exactly they're going to word this to let you know that this is not on a unit circle, I don't know. But take a look at those numbers. All right, if you look and get used to that unit circle that we've been looking at, the point 4, -3 is not on that unit circle anywhere. Okay, so hopefully you can just kind of look at this ordered pair and then know, no, it's not on a unit circle. It's going to have a radius of r. Okay, so you're going to have basically 2 steps you have to do first. Your step 1 is you have to find r. Okay, so step 1, all right, let's put find r. Okay, so find the radius. Okay, now let's take a look at this point. Okay, let's review the fact that that's an ordered pair. This is my x coordinate, and then this is my y coordinate. Okay. Now, the way we're going to do this, I don't know, let's see if we can pictorially draw this out here. I'll squeeze it on right here. Let's draw a little miniature circle here. I want you to visualize this as opposed to just memorizing how to go about doing this. I want it to make a little bit of sense to you. All right, so if I plot the point 4, -3, all right, so if I go 4 units to the right and then 3 units down, all right, this point definitely is going to be on the circle, so I've not drawn to scale here, but if I go to the right 4 and I go down 3, that's going to put that point right there. Okay, that's going to put 4, -3. All right, now a little bit later in the lesson, I'm going to refer to a bow tie triangle here. But if I've got a point down here in this quadrant, I can draw a right triangle. And it turns out to be part of our bow tie triangle. All right, we'll show you that in a little bit here. Okay, now what does this mean here? Okay, well, it means the distance from here to here was 4. The distance from here to here was -3. And I'm trying to find r, or the radius. That's what I'm trying to do. I'm trying to find radius. It's going to be all based around a right triangle, okay, inside this circle. Okay, so we know Pythagorean theorem. Okay, so instead of doing a squared plus b squared equals c squared, which is what we know is our Pythagorean theorem, all right, can't we do, this is my x, so x squared plus y squared equals r squared. All right, same concept. So x squared plus y squared equals r squared. It's still our traditional Pythagorean theorem. All right, I'm going to take my x value, which was 4. I'm going to take my y value, which was a -3, and work this out and find r. Okay, so what we got, 16 plus 9, and then that's going to be a 25. Okay, so that means my radius is going to be 5. Okay, and it makes sense. It's a positive value. It's going to be a positive distance from here to here. It's going to be a radius of 5. If you know your Pythagorean triples, all right, 3, 4, 5, then you're going to be able to get that really quick if it's a low one. If not, if these numbers are a little bit higher, you're definitely probably going to have to do this. Okay, now once you have that, okay, then all you're going to do is work on those 6 trig functions. So let's go ahead and label it step 2 here. Find trig functions. Okay, so we've got 6 of them, right? So we're going to find sine, we're going to find cosine, we're going to find tangent, we're going to find cosecant, we're going to find secant, and cotangent. Okay, all right. Now, I'm going to try to pull all this in so we can just see it because I don't want to have to rewrite. Okay, these were the original formulas that I had just wrote down a little bit ago. All right, we knew, what did we know? We know that let's go back here. Our x is 4, We know our y is -3, and we found our radius to be 5. All right, so those are the values that we're going to use. And we're going to come over here and we're going to look at our formulas, and then we're going to do a little bit of plug and chug here. So sine is y over r. Well, y is -3, r is 5, so -3/5. Okay. Cosine. What's the formula for cosine? It's going to be x over r. Okay, so x over r. All right, so I'm writing that x over r there just so we can kind of visualize there, see what we've got. So 4 over 5, so 4/5. Okay, tangent formula is y over x. Okay, so think y over x. What's your y? What's your x value? -3/4. Okay, so those come up pretty quickly using these new formulas. Okay, now if you're really confident in what you did here, okay, then these are the reciprocals. If you don't want to just automatically flip them over and take it, well, you could go through the exact same process here. All right, cosecant is r over y. All right, well, r is 5, y is -3. Now, the only thing I would say, don't write, like 5 over -3. Okay, write it like we always write negative fractions, -5/3. All right, so use a little bit of common sense there when you're writing your numbers, but other than that, we should be good. All right, same thing, you can use the formula or just take the reciprocal. So that'd be 5/4. This one, again, don't put the negative in the bottom, just go -4/3. Okay, so if you were really good with your unit circle definitions, okay, then this is a really good application of just adding one extra step, putting that point on a circle that's not a unit circle, finding that radius, okay, based on a right triangle, and then being able to come up with those. Okay, so are we good there? Does anybody have any questions there? Because I thought this was straightforward enough. We could just do maybe one example of this. If I don't hear from anybody, like unmute and ask questions if you are confused. Okay. All right. Now, the next thing I want to do, kind of shift gears a little bit. I want to take a look at what we did last week, just a little bit of review. All right. So that's why I did pre-write this down. All right. We've drawn, I'm going back to a unit circle here. We've drawn a unit circle before. When we first introduced this, we introduced these 4 points as being pretty important points. All right. Pi over 2, pi, 3 pi over 2, 2 pi, doing radian measures all the way around. I've labeled each one of those points with those ordered pairs, okay, just like we had written before. All right, on our formula sheet, you have seen this a lot. Ordered pair, cosine, sine. This is definitely something you should memorize. It's been in some previous notes. We've talked about it a little bit. All right, but I'm emphasizing it again. So each one of these ordered pairs here, the first x coordinate is cosine, and the second one is sine. And how did we define them based on the unit circle? Okay, how did we define them? Well, we said that sine was y, cosine was x. So when we were doing y and x and y over x, all right, that's the same thing right here. Sine is y, it's the y coordinate. Cosine is x, it's the x coordinate of an ordered pair. Okay. All right. Now we also I'm pretty sure it was last Wednesday when you had to do your independent e-learning, you went over reciprocal identities. Okay. So I've just rewrote them here. You should have already wrote them down at this point. And you also had quotient identities that day as well. So since that one was an e-learning day, I want to do just maybe 4 examples here of finding some angles, any of the 6 trig functions based on those 4, how you can implement these reciprocal identities as well as your quotient identities. Okay. All right. So let's start out with a relatively easy one here. All right. Let's say we're doing, say, the sine of pi over 2. Okay. So sine of pi over 2. All right. So all the 4 examples here I'm going to do are going to be these 4 points around the circle. Okay. So here's pi over 2. All right. And I want sine. Okay. Well, I know the ordered pair for right here is 0, 1. If I know that the first coordinate is cosine, the second coordinate is sine, second coordinate right there is 1. So hopefully, you can look at that in about 2 seconds. You can tell me sine of pi over 2 is 1. Okay, straightforward. All right, now let's do another one here. Let's do one that doesn't necessarily use these, but uses our quotient identities. What if I did like, say, tangent of 3 pi over 2? Okay, tangent of 3 pi over 2. All right, well, 3 pi over 2 is right here. So we started here, we went 3/4 of the way around the circle, so 3 pi over 2. Now, all right, this tangent, okay, you do have to, like, you're going to have tons of formulas, and you're going to have to make a decision, well, which formula do you really need? All right, if I try to use a reciprocal identity, this is 1 over cotangent. All right, well, from the information I'm given here, I don't know what cotangent is. I know sine, I know cosine, all right, but I don't know cotangent. So using a reciprocal identity for this is not going to help me. All right, but the quotient identities, all right, one of our quotient identities, let's go ahead and write that down. I'll just add that to our list. Again, it was from last week when you were doing this on a Wednesday. All right, your quotient identity. All right, well, what? Tangent was sine over cosine. And then cotangent was cosine over sine. All right, now again, it's not like you have to memorize new stuff here. If you are starting to piece this together, let's go back. All right, let's look at this. All right, so it doesn't matter whether it's a unit circle or not a unit circle. We've already defined tangent as y over x. You have that memorized. If I tell you the ordered pair, if this is x and this is y, and you know tangent is y over x, then you also know tangent is sine over cosine. Okay, same thing here with cotangent. It's x over y. Well, if you know the first coordinate is cosine and that second coordinate is sine, then this one's already memorized too. Okay, so you've just got to start. It's all connected and it's all put together. So here, what I want to think is okay, well, I'm going to do sine over cosine, not writing that necessarily in a real good way. This is more me thinking. All right, I'm at 3 pi over 2. Well, my sine value is -1. My cosine value there is 0. All right, so can I divide by 0? No, we know we can't. So that means this value is undefined. Okay, and then this is what I'm thinking because tangent is sine over cosine. So then I'll come up, pull my information, see what kind of thing I've got in my fraction. I know I can't divide by 0, so that value is undefined. All right, let's also take a look at maybe, say, cosecant of pi. Okay, so if I'm working with a lot of reciprocal identities, I'm working with my quotient identities here. About the only thing I see here that's going to do any good here is 1 over sine. Okay, well, that's good because if I'm at pi on my circle, I know sine and cosine. So this is a good thing. So here, all right, I'm going to be thinking 1 over sine. And if I want to be a little more mathematical than I was here, if I want to do 1 over sine pi, that's less writing the steps out just a little bit better there. Okay, well, what is sine pi? All right, well, here's pi. Sine is 0. All right, so again, this turns out to be 1 over 0, which is undefined. Okay, let's do one more before we move on to something else here. Let's do maybe, say, secant of 2 pi. Okay, again, think about all the different formulas that you've got and things that you know on your unit circle here. All right, so secant is 1 over cosine. Well, am I going to know a cosine value? Yes, I'm going to know sine and cosine right off the bat because it's going to match those ordered pairs. All right, 2 pi would be what? All the way around the circle. Okay, so I'm back here at this point where I started, all right, which the ordered pair is 1, 0. Okay, so secant 1 over cosine. And again, if I wanted to show a little bit better work than I did earlier here, I would write cosine of 2 pi. All right, well, cosine is our first coordinate. That's a 1. So the bottom there is 1. So 1 over 1, 1 divided by 1 is 1. Okay, so this is just a way to implement some of those formulas. And if you try to use a formula and then you can't find a value to plug into it, then you know that's not the right formula and you got to find something else. All right, so this was just kind of touching up from the lesson from last Wednesday just to make sure everything was falling into place. All right, does anybody have questions on this? All right, actually, you're just going to have to start playing around with this kind of stuff, use the formulas, use the unit circle, and the more you do this, the better you're going to get at this. Okay, now what I thought I would do is focus on a couple types of questions that you're going to see in your MathXL. Okay. We're going to talk about a little bit about special right triangles. All right, you did special right triangles in geometry, but that was probably a long time ago. Okay, so we're going to review those a little bit and then kind of look at what MathXL is doing and what they're expecting you to do. Okay, so let's label this as, let's say, use special right triangles to evaluate the expression. All right, I'm pretty sure in MathXL they actually kind of word it just like this. They're wanting you to do this a certain way. Okay. All right, so you're going to see a problem that's going to say evaluate. And then you're going to see a great big long expression. Okay, so you might see something like sine pi over 3 cosine pi over 4 minus tangent pi over 4. All right, now if they are specifically wanting you to use special right triangles, then these angle measures are either going to be 30 degrees, 60 degrees, or 45 degrees, because those are your special right triangles. Okay, so now let's review, since I know it's probably been a long time since you've done your special right triangles. And special right triangles can be taught a variety of different ways, so I don't know how it was taught in your geometry class. All right, but I'm going to kind of try to draw this a little bit more to scale than I normally do. Okay, so clearly this side is shorter than this side. So I'm going to put my 30 degrees up here. I'm going to put my 60 degrees here, and this is my right triangle. Okay. All right. In a 30-60 right triangle, this one is a 30-60 right triangle. Okay. If you remember doing these, okay. The side across from 30 is 1. The hypotenuse is 2. And the side across from 60 is square root of 3. Okay. And I believe this is on the reference sheet, very small on one side of the reference sheet that I've already given you. Okay. Now your other special right triangle, okay, is your 45-45 right triangle. And technically a 45 right, 45-45 right triangle would be what? Those two sides would be the same. So attempting to kind of draw the scale there. All right, this side and this side would have to match. That would make this a 45-degree angle. That would make this a 45-degree angle. Okay, so this one is a 45-45 right triangle. All right, and then from there, if these two sides match, they have to be the same. So this side would be 1, this side would be 1, and the hypotenuse is square root 2. Okay, and those are right triangles. You could do Pythagorean theorem. You could verify that those sides match that way. All right, now, in MathXL, they're purposely, I think, they even give you the right triangles, maybe the special right triangles there, so you're trying to connect there. Now, the only other thing is when we do these special right triangles, we do them in degrees. MathXL is going to do this in radians. So the other thing you've got to be able to convert from radians to degrees or have them memorized. I'm hoping at this point you've done it enough that, like pi over 3, you know, is 60 degrees. All right, anything in that first quadrant especially kind of just should be memorized. Okay, so pi over 4 is going to be your 45 degrees, and then your pi over 6 is your 30 degrees. Okay, so if you've got those memorized, that's going to help tremendously in doing this. Okay, all right, now it's a right triangle, so we're going to have to do some right triangle definitions here. Okay, this is sine of pi over 3. All right, well, pi over 3 is 60 degrees. So here is 60 degrees, so I'm using the 30-60 right triangle. Sine is opposite over hypotenuse, okay? Opposite over hypotenuse, so this value right here has to be square root of 3 over 2. Okay, I'm using my right triangle definitions. Sine of 60 degrees, opposite over hypotenuse, okay? Cosine of pi over 4, okay, well, pi over 4 is our 45 degrees, so we're going to be using the 45. All right, cosine of 45 is cosine of 45. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, now I am going to do a little bit more work here because I don't want you to write it like that. Let's see, let's go to green. Okay, so cosine 45 degrees, we said was what? Adjacent over hypotenuse. All right, which is going to be 1 over square root of 2. All right, but let's go ahead and rationalize that. All right, so let's multiply by square root 2 over square root 2. So cosine of 45 is square root of 2 over 2. All right, I think when you multiply this, it's just going to be a little bit easier there. Okay, so square root 2 over 2. All right, minus tangent of pi over 4. All right, so pi over 4 again is 45. Tangent, all right, is going to be opposite over adjacent. So 1 over 1 is going to be 1. Okay, and then from here, we can multiply this out really easy. This is going to be square root of 3 times 2 is 6. 2 times 2 is 4 on the bottom there, minus 1. Okay, we're doing this by hand, not on a calculator, as you can tell. 1, if I've got fractions here and I'm trying to subtract, I need to make this have a common denominator. So I'm going to have radical 6 over 4 minus 4 over 4. And then this is where you're going to get those answers, radical 6 minus 4 over 4. Okay. All right. So the thing is, you know, you're not going to want to do this. Like if some of you have been trying to just rely heavily on that calculator, all right, they're not going to want this as a decimal. They're going to want the answer to look like square root of 6 minus 4 over 4. Okay. So you're using those special right triangles. All right. You can also use your unit circle as well, but there's in the directions, they're specifically telling you to use the special right triangles. But if I, you know, in the unit circle, 45, 60, and 30 is in that first quadrant. So you can get your cosine, sine, and tangent right off there. And if you copied your unit circle down exactly like mine, that extra value at each point along the circle, that extra one that I had written out there was your tangent value. Okay. So it's already pre-calculated for you there. So I just thought I would kind of address this because I know that it's going to show up if it hasn't already in MathXL, and you're going to, you know, need to get the answer looking like this. All right. They're not going to want that decimal answer. Okay. All right. So are we good there? See if I have any questions. Okay. All right. All you got to do is unmute your mic and ask if you've got some questions. Okay. So, because we don't want me to just keep yakking and nobody asks questions if you're lost. All right. Another thing that you're going to see in your MathXL, okay, types of questions. They're going to ask you to find the exact value of each trig function. Okay, so pretty simple little directions there. And then what they're going to do is they're going to tell you that maybe say cosine of theta is equal to -4/5. And then they're going to give you a clue. So the clue could be anything, but they're going to tell you maybe say theta is in quadrant 2. Okay, they could be as straightforward as that for the clue. They could also say theta is in between 0 degrees and 90 degrees, which would tell you it's in the first quadrant. Okay, so this can be phrased anyway. They could do an inequality right there even. Okay, so they could, just to show you, they could say 90 degrees is less than theta is less than 180 degrees. All right, well, so what's that tell you? It tells you theta is in the second quadrant. So it doesn't matter how they phrase the clue, you just have to translate that so that you can figure out what quadrant is in. Okay, now earlier I referred to a bow tie triangle. All right, and again, this is drawn on that reference sheet. All right, someplace on that reference sheet that I had given you. All right, your bow tie triangle. All right, we all know what a bow tie looks like, right? Not that I can draw a really good bow tie. They're bow tie. Okay, so this is our bow tie triangle. All right, looks like a bow tie. All right, and it's drawn on, notice I drew it on the X and Y axis. All right, which means that every time that I need to draw a right triangle in the first quadrant or second quadrant or third quadrant, this is how the triangle is going to sit. All right, so if you remember back to the very first question that I did, let's see if I can pull that back up just so we can look at it. All right. All right, this is the problem that we had done earlier. All right, and I plotted that point and I went to the right 4 and I went down 3. All right, well, the triangle matched. I knew I was in the fourth quadrant. I knew how I had to draw that right triangle. All right, it's part of the bow tie triangle. So based on what quadrant you're in, this is how you're going to draw your right triangles. Okay. All right, now So the first thing I would do, we know theta is in the second quadrant, so we know this is what our triangle is going to look like. All right, and we've got this. So again, I'm going to do this in a couple different steps here. Let's go with step 1. All right, I need to draw a right triangle just so I can picture this out. So I'm going to draw a right triangle. Okay, and I'm going to put it in the second quadrant. I'm going to make it look like my bow tie triangle. Okay, so again, I'm not going to draw the whole darn thing because we don't need all of it. I just need to know it's in the second quadrant here. Okay, so there's my right triangle. Okay, here would be my theta. All right, now let's stop and think about this. All right, cosine. All right, cosine. Write this down. Cosine is going to be what? All right, it's going to be x over r, right? Almost forgot what my definition was. It's going to be x over r, okay? Cosine from our not unit circle here. Okay, so my x value, does this make sense that -4, if I started here and I went to the left, does that make sense that my x value would be -4 if I'm trying to plot this point, -4? Okay, so it would be. So my -4 goes here. All right, now definition of cosine was x over r, which correlates and tells me that that 5 has to be my radius. So the 5 goes here, and this is the value I don't know. Okay, so how do we do it? It's a right triangle. I'm going to use x squared plus y squared equals the radius squared. So my x squared is -4. I don't know my y, so y squared. My radius is 5, 5 squared. So 16 plus y squared equals 25. Again, that's going to be 9. So y equals 3. All right, so this value right here is 3. So I need to use the bow tie triangle. I need to take the information they give me. I need to remember what the definition of this is. All right, I need to draw that right triangle. I need to label my sides, figure out the missing side. All right, so now I know my x value, I know my r value, I know my y value. So if I want to find all 6 trig functions now, okay, so step 2, find trig values. I can do it, okay? So sine, and then cosine. Well, they gave me cosine up there, so I really don't need to write that one down. That's the one they gave us. All right, and then tangent. And then, let's see, this would be cosecant. This one would be secant. And this one is cotangent. All right, so let's go ahead and just do the sine one. Sine, okay, look at your right triangle here. Sine is opposite over hypotenuse, opposite over hypotenuse. So this one is 3/5. Tangent is opposite over adjacent. Here's my reference angle, opposite over adjacent. I got a 3 and a -4. So again, put that negative up where it needs to go. So -3/4. All right, and then technically to get these 3, you could do and run those definitions, or you could take your reciprocals. All right, so cosecant is just going to be the 5/3, that flipped. Secant, all right, again, put that negative in the top when you flip it around, -5/4. Cotangent, when you flip that one around, keep the negative in the top, -4/3. Okay. All right, so the farther we go into this trig, the more thinking you're going to have to do and the more you're going to have to write down. All right, the better off you are. If you're drawing your right triangles, you're really using those formulas. So keep that reference sheet handy. All right, keep your notes handy. All right, and take it step by step. And I think we should be pretty good. But this question, this type of question comes up pretty frequently in MathXL. So I kind of thought we needed to definitely address it. And about the only difference is, they'll give you any trig function here, go with whatever those definitions are, and they're going to give you any clue, and it could be in any format. That clue could be in any format to tell you what quadrant that this angle is in. All right, so because of the things that we covered yesterday,